All right, hello. So at this point, we have taken a calibrated VELMA run for Watershed 1, and it's working pretty well. Pretty good Nash Sutcliffe, and looking at the annual results year to year, it's functioning pretty good. There's room for improvement, but it's functioning okay. And so then, what VELMA is really designed for, though, is what if scenario sort of questions. Like, what if this watershed that has or has not been clear cut was clear cut? Or what if there was a bigger riparian zone? Or what if there was thinning? What if we changed the soil structure? What if the climate drivers were different? Things like that. And so here, in VELMA's most straightforward case is to clear cut a forest. So that's what we're going to do as a comparison simulation. And to do that, what you want to do is we take our initial run that is of a historic state, the 1980 through 1989 simulation we have here for Watershed 1, and we will then add in a disturbance event that may or may not have happened. In this case, there was a clear cut, but it was several decades earlier. Well, this starts in 1980, so I don't know the exact year Watershed 1 was clear cut off the top of my head, but it was like late 60s. So, but for our simulation's sake, then how will that then impact the hydrology in the watershed? And that's what the papers that were provided, more paper, and the Jones paper, highlighting those papers focus on observed information on what happened with the either watershed in one of those papers, comparing an old growth versus a clear-cut recovering forest state. The other one then focused on actually measuring the flow rate of young trees versus old trees. And so that's exactly how VELMA is designed and built as a mechanistic model, is going from stand level to small catchment level to the hill slope interactions to the large scale full watershed. And so those are great papers, and those papers are actually used to build in a stand age effect into the model so that you could replicate those types of disturbance actions. And so here what we're going to do is not really validate the model, but really just go through a what if scenario, which is a classic VELMA exercise. And you don't have to do even just, here we're going to do a straight comparison, just baseline VELMA model versus clear cut. And that, again, did happen at one point, but did not happen when we're going to do it here in the 1980s. And so to add any disturbance into VELMA, you simply want to load your VELMA simulation, most likely your baseline scenario, which is what we have here. So this is the same scenario we ran. This is the same scenario that, let me pull up here so we're all on the same page for sure. Where is it? Same scenario that is the Watershed 1 30 meter under the results that the prior video we were going through standard VELMA outputs. And so what we're going to do here is, I'm right out the gate so I don't mess anything up, I'm just going to change the name here. I'm just going to tag on CC for clear cut. And I could even save this, but just for the fact that that's there is sort of a safeguard that I don't accidentally overwrite my baseline calibration XML setup. So now we're venturing off into the what if scenario. And here, if I clear all my filters and look at disturbance, I don't have any disturbances in this setup. So we're going to add a new one. So I go to Edit, Disturbances, Add a Disturbance. So you should be going through these steps because we're going to add a harvest event. There's a variety of disturbance types set up in VELMA, but you want to find the Harvest LSR disturbance model, which is Harvest Leaf Stem Root. That's what LSR stands for. And we'll just give it a name. Whoops. clear cut. Load that in. And now everything is defaulted here, so there's a few things we need to work through. And so what I'm going to do is actually put this next to this setup, so we get a little side by side. So I just have this dummy XML, that's why it's bolded out, not runnable. This is not a VELMA setup. I just use this to store a variety of parameters. And if I then, at least on my end, you don't need to do this, you can just work from the video. Oh, actually I can't do that. Let's see, we have to sort by parameter type since so much is not filled in. So what's going to happen here in this disturbance, let's just focus on the left side here. We're going to perform a clear cut, but under certain required conditions for the forest structure state and the simulation timing are both going to be impacted here. And so age threshold of 0, we'll just leave that for the clear cut. That basically says you have to be over 0 years old. But maybe in the simulation you don't want that. Maybe you want a clear-cut forest that must be at least 80 years old. Or maybe you want to even set in a range where you must be between 30 and 50 years old. So things like that are possible. We're just going to leave it at 0. That way we clear-cut everything. How much are we going to clear-cut? So that's what all of these parameters are set to. So again, prior video I mentioned AG stem is above ground, BG is below ground. So how much of the above ground stem are you going to harvest off of a fraction? All these are fractions, 0 to 1, 1 being 100%, 0 being 0%. And then so AG stem off-site fraction. So an interesting thing with VELMA, you can harvest something. If you harvest 100% but have nothing go off-site, you cut the tree down. And the biomass is still laying there on the ground. It's still on the surface layer. It just got transferred from a live pool to a dead pool. But if you were to log AG stems for the purpose of hauling them off to turn them into lumber, then you would want to both harvest and remove offsite. And below ground stem, at least in Northwest systems, we don't harvest the bole or below ground. Normally just gets cut with a chainsaw, and the base of the tree becomes a stump. And so, but same idea. How much is harvested versus how much goes offsite. Same with leaf material, root material. Oh, I was kind of sorry. Below ground stem versus root. Those aspects of the two parts of the tree are separated in VELMA. Kind of like stems and leaves as well. And so all of these aspects are the tree specifically. And so you got to, for various simulations, you got to think through these. But for this one, we're just going to take and turn these all into 99%. We normally don't ever set these to a full 100% because that can cause pools to go completely empty, and then you don't end up with forest recovery, which is not really ever the case. There's always a little bit of seedlings, or you could even simulate in VELMA plantings and get the recovery to start occurring a little bit sooner. So 99% or 0.99 works well for a clear cut scenario. But you could think with these. You could play around with, well, what if I did forest thinning? Well, then you wouldn't want to be doing 99%. You'd want a lower level of stem and a leaf biomass. So you'd want to leave something there, just like an actual thinning disturbance would. A filter map is an optional thing, so we don't need to worry about it. All of our simulations are loop-wise. We're only working on one loop. We won't get into these videos, maybe some advanced videos on what looping will do for you in VELMA. J-Day, you could anywhere between 1 and 366 you could set it to. I'll set it to like 190. I'd have to look up a J-Day calendar. But what J-Day is January 1st is 1, January 2nd is 2. But when you get to the end of the month, like January 31st, February 1st is not 1st, but rather it's 32. So 31 days in January plus 1 for February, and just moves on. So it's just a counter per day. Active years, you want to pick some day that's within the realm of your simulation. So we're running from 1989. So for this to actually occur, I need to have a date somewhere within that range. So I'll do like 84, maybe 85. Let's go with 85, about in the middle of the simulation. Age modification, just leave it as a +0. But what that does is it resets everything to 0. So the new trees start at age 0. Your cover ID is important. So for us, our coverage, we only have one cover, but our unique ID is 1, meaning that in our map, everything has a value of 1. Every pixel is a 1 for conifer. But this could change. So you could clear cut all the conifers, but not the alders, and not the ag, or you could clear cut the alders. It just depends on how your map is set up. We have a simple map. So for our disturbance, we're going to cut all the 1s, which is all the conifer trees. And our filter IDs link to our filter map, which are an optional feature. These are in place because maybe you have everything might be conifer, but some might be owned as private, but yet other trees might be owned federal, others might be state. So this is a pretty clear case for this is land ownership, but it could be used for all different types of things. So that's it for filling this out. And then at this point, we just want to go back to our parameter page. It'd be really good to add in some notes on that's what this is always for. So we just say that started with baseline setup and added a fake clear cut scenario for year 1985. Something like that. Sometimes get quite involved, but for this, that's good enough. And then save it. You don't want to hit run here. You get a warning. So I'm going to first save this, and then I'm going to hit start and let it go. I'm trying to keep my videos under 15 minutes, but we'll let this play out and we'll see. Oh, I should have went to full screen. FYI, it's always best to run VELMA in full screen because the graphs will scale appropriately until you hit start, and then they're fixed. So I'll just let that go. But I will go to see if I can get there before it's too late. This is a pretty fast watershed because it's pretty small, but looking for the harvest. Well, we could look at this summary. I don't want to miss it. We're in 82 going to 83 already. So the biomass right now is pretty high. This is a older forest. You know, for Doug firs, they're maxing out typically over 30,000 grams carbon per meter squared, at least for on the west side Cascade system. So if you remember 1985, J-Day 190, which is sometime in, I believe, June, we want to be watching this biomass map. And I really wish I was on the harvest one because you could see the transfers going on. Let's just watch this. There we go. May have been even July there, but all of a sudden now full clear cut. Our biomass level plummeted to near 0. It's not 0, but it's pretty close. 99% drop. And there was some transfers. You'd have to go back and compare, but detritus and humus pools. And then our net parameter production also plummeted because we don't have much trees. So let this run, and then in the next video we're going to compare these results to our baseline results. Thanks.